Okay. Okay. The artificial intelligence in medicine. In this content, we are going to see three topics: the artificial intelligence, brief history, type of AI, the essential math for AI, use of AI in everyday life. The second one is artificial intelligence in medicine, the virtual branch, the physical branch, and at the end, the article called Artificial Intelligence for Breast Cancer Detection in Mammography. Okay, the artificial intelligence, in brackets, AI. A brief history. The artificial intelligence is probably the most complex and astounding creation of humanity yet. And that is disregarding the fact that the field remains largely unexplored, which means that every amazing AI application that we see today represents merely the tip of the AI iceberg, as it were. AI, described as the science and engineering of making intelligent machines, was officially born in 1956. We got four types of AI. First is the reactive, which those are the oldest form of AI that have extremely limited capability. They emulate the human mind's ability to respond to different kinds of stimuli. Those machines do not have memory. This means such machines cannot use previously gained experience to inform their present actions. A popular example of a reactive AI machine is IBM Deep Blue, a machine that beat the chess grandmaster Garry Kasparov in 1997. The number two, the limited memory. Nearly all existing applications that we know of come under this category of AI. All present AI systems, such as those using deep learning, are trained by large volume of training data that they store in their memory to form a reference model for solving future problems. Almost all present-day AI applications, from chatbots, medical diagnosis systems, and virtual assistants to self-driving vehicles, are all driven by limited memory AI. The last two, the number three and four, the theory of mind and self-aware, are merely as a concept, and it's a work in progress. The theory of mind is the next level of AI system that researchers are currently engaged to innovating. A theory of mind level AI will be to better understand the entities it is interacting with by discerning their needs, emotions, beliefs, and thought processes. The number four, the self aware. This is the final stage of AI development, which currently exists only hypothetically. The self-aware AI, which self-explanatorily is an AI that has evolved to be so akin to the human brain that it has developed self-awareness. Creating this type of AI, which is decades or maybe if not centuries away from materializing, is and will always be the ultimate objective of all AI research. Well, we have the essential math for AI. This is something that if you want to develop your own AI, you must have like a solid base. The first one is the linear algebra. You must know the vectors, the matrix, eigen values, and eigen vectors. Second topic that you must know is calculus. You must know about functions, grading algorithms, and scalar derivative. The last one is the probability. You must know about some axioms, some basic rules, random variables, continuous and discrete, and Bayes' theorem. The use of AI in everyday life. Okay. First of all, guys, we must understand that this is not the future. This is the present. All our everyday life, it's now has an AI. So we must understand that this is something that is happening just right now. We can see an application of AI in things like smart cars, drones, smartphones, media streaming services, banking, finance, navigation, travel, video games, online ads, social media feeds, security, healthcare industry, e-commerce, etc. Now, let's start with the main topic, the artificial intelligence in medicine. We have two branch, the virtual and the physical branch. In the virtual branch, there are three types of machine learning algorithms: unsupervised, supervised, which has the ability to classify and predict algorithms, and the reinforcement learning, which use sequence of rewards and punishment to form a strategy for operating in a specific problem space. An example of success in medicine is the unsupervised protein interaction algorithms that lead to novel therapeutic target discoveries. The methodology use a combination of adaptive evolutionary algorithms and state-of-the-art clustering methods. Name evolutionary engines Markov clustering, which is permitted prediction of over 5,000 protein complexes. We can see here pictures of about what this AI is capable of. The next is the physical branch. This, I believe, is, at least for me, one of the most beautiful part of the AI, because we can see some kind of application like medical device and some physical objects like robots taking part in the delivery of care, called the care robots. Perhaps the most promising approach is the use of robots as helpers. For example, use of robots to interact with autistic children, or in surgery as assistant surgeon like Da Vinci medical robot, which is this one. Okay, let's start with the artificial intelligence for breast cancer detection in mammography. This is the article. The breast cancer. The breast cancer is the most common cancer in women. It is still a major cause for cancer-related mortality, accounting for approximately 500,000 annual deaths worldwide. Yesterday, I saw an article which means that the Latin women has a higher probability to get cancer, and even in younger women. So this is some very serious problem. The digital mammography, or DN, the AM is a type of mammography that records the radiography image electronically in a I'm sorry. The DAM is a type of mammography that records the radiography image electronically in a digital form. We can see how the radiology is taken, but with an X-ray beam, and then the image is saved in a computer. For this article, we took the digital mammograms, or DIM2, and it was called a set of DIM examination that were read by multiple radiologists during other unrelated and previously completed retrospective, multi-reader, multi-case MRMC observed studies. 9 distinct DIM datasets were obtained from different institutions across Europe and the United States, We're going to see the table in the next diapositive. The dataset. Each dataset consists of 3 items: the digital mammograms, the radiology score of each DIAM exon, their ground truth. Okay, for the methods, the system uses deep learning convolutional neural networks, feature classifiers, and image analysis algorithms to detect calcification and soft tissue lesion in 2 different models. The mammograms used in this study have never been used to train, validate, or test the algorithms. The system provides a continuous score ranging between 1 and 10, representing the level of suspicion of cancer presence. The AI system is trained using a database containing over 9,000 pictures of mammograms with cancer and 180,000 pictures of mammograms without abnormalities. Remember that to train an AI, we need a very large amount of data to become the AI very efficient. The statistical analysis. The accuracy of the radiologist was compared to that of the AI system with a non-inferiority null hypothesis based on difference in the area under the receiver operating characteristics, ROC curve. We have the abbreviation ROC, receiver operating characteristics, and AUC, area under the curve. Only cases with malignant lesion were considered positive because sometimes you can obtain some negative image. So here in this article, we will only focus on the positive lessons. You can see right here the table and the different countries with the total amount of radiologists, which is 101. And this comparison, the data set listed in this table is compared with the rated average AUC against the AUC of the AI system, which means that in this table we got an AUC of the radiologist and the AUC of the AI system. We use the public domain IMRMC software, which can handle arbitrary studies designs, including the split plot design resulting when pulling dataset as in the study. You will see in the next diapositive the next tables. And this performance comparison for each dataset, the AUC and the operating points were compared between the AI system and the average of radiologists for each dataset and against each individual radiologist. To make the another analysis of the variance was used to compare the AUC between the AI system and the average of radiologists based on the methods by Gallas. Finally, the sensitivity at the radiologist specificity was compared between the radiologist and the AI system as determined by a screening scenario threshold. The results of this article in the figure number 1, we received the operating characteristics curve comparison between the reader average radiologist and the artificial intelligence AI system in terms of area under the curve. We can see in the continuous line the radiologist the sensitivity and between the against the AI system, which you can see here clearly that the AI system got a little bit higher sensitivity than the radiologist. In the next figure, in the number 2, the difference in area under the receiver operating characteristic curve between the artificial intelligence and the AI system and each radiologist. We can see again the comparison, and the AI system again got a higher level in the average radiologist. And finally, in the next figure, the difference in percentage of the sensitivity between the artificial intelligence and each radiologist as the specificity of each radiologist, considering by RADS and over as a positive recall. Again, we can see that the AI system got a higher level, but it's something curious because when we put the AI system against the best radiologists, they win. And maybe these factors are considered because we are not counting many other variables. Okay, the AUC of the AI systems was statistically non-inferior to that of the 101 radiologists. The AUC difference was slightly higher for the AI system at the range of low and mid specificity. The system had a higher AUC than 62 of 101 radiologists and a higher sensitivity than 55 of 95 radiologists, as we saw in the past diapositive. Its performance was always lower than the of the best radiologists. It's something that I will talk. The best radiologists got the best qualification, but this is because we are not coding many other variables. Okay, the conclusion. The AI system achieved a cancer detection accuracy comparable to an average breast radiologist. It could also be used as an interactive decision support tool, and the possibility of using such a system in countries that lack experienced breast radiologists, which it could mean that we could save many more lives in those countries. Well, thank you, and now I am able to answer your questions. So, yeah, it's everything.
Thank you, Osvaldo. I have a question. Do you have what do you recommend to healthcare workers to start with working with artificial intelligence? How can we start understanding? Because it's hard now, you know, math and stuff like that.
Okay, thank you for the question. It's something, guys, that I need that you understand. But you don't need to be an engineer and a physicist and a mathematician to learn how to apply the AI system. You can read about. I will pass in the group at the articles. But what you can do is, if you identify that you can make some work, some job a little bit faster, or with some kind of human help, you can go with one engineering, and you can say, hey, I want to develop an application which can help in this area to make things faster or even more with more accuracy. So yeah, you can apply the AI system in everything. If you want to make something that, I mean, if in your job you make something that is very repetitive, you can program an AI which can help to make that job. So yeah, you can go with some engineer and can help to develop such a that application. And that will be my recommendation. And as I told you, I will I will look for some articles to go ahead with the AI system to understanding how it works. Um, it is something complex because, as you said, because all the maths what we need to learn, but you you can you can make the other part of the AI system, which is that you must. Okay, I mean, if you want to make an AI system, first of all, you must need to think in the problem and start to write down what you want that AI to do, and then the engineer is going to get in charge to transform that human language to the mathematician language, and finally to the programming language to develop the AI. Because it's not only using the maths, you need to know about some program language like C Sharp, C, Python, and Python is the most strongest in this area.
Okay, thank you.
You're welcome. Anybody? No.
I guess no.
Okay. Well, guys, thank you for joining us today. I don't know if you are going to say something, Kabir. Or
There's a website working with AI that makes you a brief overview of systematical reviews. That's very useful for quick reading of articles. I think it's called Robot Reviewer, I think.
okay, yeah. As I told you, you can figure out how to apply the AI system in your everyday life. You don't need to be an engineer, but yeah, you can find a problem. You can try to solve it by joining force with any other areas of study. And yeah, we can start to develop an AI for each case that we could use. I don't know, maybe if here, just here in my house, if I want to to start to save some money for something, or I always spend a lot of money, I can start to develop an AI system to help me to control that all my bills and everything. So yeah. Also, I heard that there exists some AI system that make art. It can generate pictures. Uh, he goes deep on the web and search how he can draw some kind of animals, and that's the beauty. And also, I heard too that someone developed an AI system to make music, which is something amazing. It's just awesome. Let's see. you want to care your body, you can see all the nutrition. You can develop an AI system which can watch your daily eatings, your foods, your exercise, and it can start to generate that data, which it will help you in future um, moments. Or yeah, that's all. I think the AI system has many applications, a lot, and it's the future. Well, it's the present, I will say.
It's really interesting. Well, if there's no questions for Oswald, I think we can finish our meeting for today. Thank you, Oswald, for your presentation and everyone for joining us today.
Exactly.
And we'll see
Thank
you
you.
next month.
See you.